All right, so picture this, you're sitting down to a meal, right? Fresh salad, maybe some fish grilling on the side, and to top it off, some mushrooms.
Tree sounds pretty amazing, right?
Oh, absolutely. But here's where things get interesting. This isn't your typical farm-to-table scenario. We're talking about an aquaponics system so advanced it can produce all of this off-grid.
That's right. We're going deep into a patent today that truly pushes the boundaries of sustainable living. It outlines a system so self-sufficient it could thrive in a desert, the Arctic, maybe even space.
Now, I know what you might be thinking. Patents can be a bit, well, dry, right?
Yeah, they're not exactly known for their thrilling prose.
But trust me on this one, this patent reads like a blueprint for a sustainable future. And to make it even more exciting, we're focusing on the aha moments, the parts that really get you thinking, why didn't I think of that?
It's like peeking behind the curtain of innovation, getting a glimpse into how inventors tackle big challenges. And believe me, this patent is packed with clever solutions.
Okay, so let's dive right in. Imagine a greenhouse, sunlight streaming through. Actually, you know what? The patent goes even further, specifying triple-walled polycarbonate for insulation.
Oh, wow, they really did think of everything.
Right. Talk about attention to detail. But that's what I love about these deep dives. We get to see the level of thought that goes into these inventions.
It's that meticulousness that sets this patent apart.
Absolutely. Now, inside this high-tech greenhouse, we've got ourselves a pretty substantial fish tank, probably a couple of 100 gallons or so.
Big enough to support a decent harvest, I'd imagine.
Exactly. And while I'm picturing tilapia swimming around because, they're pretty adaptable, the patent mentions that the type of fish could be adjusted based on the environment.
Which makes perfect sense, right? You'd want a species that thrives in the specific conditions, whether it's a desert climate or a colder region.
Right. Adaptability is key. So we've got our fish swimming happily, but what about the ponics part of aquaponics? That's where the grow beds come in, right?
Absolutely. Imagine these grow beds encircling the fish tank, all connected in a closed loop. This is where the magic happens. The water from the fish tank, now rich in nutrients, gets pumped up to nourish the plants.
Hold on, pumped up. That's where I stumbled at first, because if we're going completely off-grid, traditional electric pumps are out of the question.
Ah, but this inventor had a trick up their sleeve.
Air.
Air. Like just plain old air.
You got it. They incorporated something called geyser pumps. Think of those toy rockets you pump up, same concept. Air pressure is used to push that water upwards.
So no electricity guzzling pumps, just good old-fashioned air pressure moving hundreds of gallons of water.
Exactly. Elegant in its simplicity, wouldn't you say?
Absolutely brilliant. And once the water reaches the top, gravity takes over, naturally bringing it back down to the fish tank, creating this beautifully efficient cycle.
It's like they've taken inspiration from nature itself, harnessing natural forces to create a truly self-sustaining system. And that's just the water flow. This patent goes even deeper, talking about something called N-way redundancy. At first, I thought, oh boy, here comes the technical jargon.
It does sound a bit intimidating, right? But it's actually a pretty straightforward concept, especially in this context.
Okay, so break it down for me. What does it actually mean?
Well, think of it this way. Remember those old Nokia phones? The ones that could survive practically anything.
Yeah, these things were indestructible.
Exactly. This aquaponics system, it's built with that same nothing can stop me mentality. Every critical component, and I mean everything, the air pumps, the solar panels, everything has multiple backups. So if one part decides to take a break, the whole system, it just keeps humming along.
So it's like the system has a backup generator and then a backup for that backup generator and then another one just in case.
You're getting the idea. For example, let's look at the air tank system. The patent describes this whole setup, where solar panels are the primary power source. They charge a whole bank of batteries.
Okay, makes sense so far.
And then those batteries, they power the air pumps, which then fill the tanks that provide the air pressure for the entire water flow.
Okay, got it. Solar charges, batteries run the air pumps. But where does the redundancy come in?
It's built in each level. So let's say the sun dips behind the clouds, right? You've got the battery backup ready to seamlessly kick in. And then let's say one of the air pumps decides to act up. No problem. Other pumps are standing by, ready to pick up the slack, drawing air from the full tanks to keep that pressure constant.
Wait, so there are multiple pumps, A and D, multiple air tanks. This inventor was not messing around.
Absolutely not. And it's not just about having spare parts. It's about how cleverly they're all designed to work together. The air tanks, for example, they're not just sitting there in isolation. They're all connected so that if one tank starts running low, the others automatically compensate.
You're saying this thing practically regulates itself.
Essentially, yes. The patent goes into great detail about the plumbing and sensors that make sure that even if a part of the air system fails, the others instantly pick up the slack, keeping that constant flow of air going to power those geyser pumps.
It's like this aquaponics system has a brain constantly monitoring and adjusting. Okay, now I understand why they call it in-way redundancy. It's not just about backups. It's about creating a system that's almost, well, impossible to break.
Exactly. And remember, this level of resilience, it's not just for show, right? This system is designed for some of the most extreme environments imaginable. Think scorching deserts with limited water. Think icy tundras where traditional agriculture is simply out of the question.
Hold on, deserts, Andy, the Arctic. It can handle both of those extremes.
That's the beauty of this design. It's adaptable. It's resilient. And if that wasn't impressive enough, the patent even hints at its potential for.
Don't tell me space.
You got it. While it's not the primary focus of the patent, it does mention the potential applications of this technology for space exploration. Imagine a self-sustaining food source for astronauts on a mission to Mars.
Okay, now that's just mind-blowing. Air-powered, super reliable, and potentially spacefaring. This patent is like something straight out of science fiction.
It is pretty remarkable.
Okay, before we launch ourselves into orbit here, let's come back down to Earth for a second. Because this patent, it had one more surprise up its sleeve. Something I definitely didn't see coming. Mushrooms.
Ah, yes. The mushroom integration is really where things get interesting. You see, the water that cycles through those grow beds, it's perfect for the fish and plants, but it's not completely spent. It still carries nutrients, and that creates a really ideal environment for certain types of mushrooms.
So not only are we talking about a system that's super efficient in terms of water and energy, but it's also finding ways to get even more out of those resources.
Right. It's like this closed-loop system where nothing goes to waste. And the really ingenious part is how they've integrated the mushrooms, because mushrooms, they need a particular environment to thrive, right? It's got to be cool, bit humid, and definitely not as bright as what your plants would want.
So how do you create those conditions in a greenhouse that's also designed to grow plants?
Well, that's where the design gets really smart. They've incorporated these things called evaporative cooling pads, placed strategically near the mushroom beds. So these pads, they use evaporation to cool down the air, creating that perfect little microclimate for the mushrooms, humid and cool, just how they like it.
It's like a little mushroom oasis right there in the greenhouse. And the CO2 that the mushrooms release during respiration, the plants use that for photosynthesis.
Exactly. It's this beautiful symbiotic relationship happening right there in the system. And it doesn't have to be just one type of mushroom either. The patent mentions cultivating a variety, from oyster mushrooms to shiitakes. You could even experiment with some more exotic varieties if you wanted to.
Talk about a gourmet garden. So we're talking fresh fish, a variety of vegetables, A&D, gourmet mushrooms, all from a system that practically runs itself.
Yeah.
It really does sound like the ultimate sustainable living dream.
It really highlights the possibilities when we start thinking outside the box, right? This isn't just about building a greenhouse. It's about reimagining how we produce food, how we manage resources, how we approach sustainability as a whole.
Absolutely. So for our listeners who are now just as captivated by this patent as we are, what would you say is the big takeaway? What's the aha moment that they should carry with them?
I think it's the power of innovative thinking, because this patent, it's not just a set of instructions for building an aquaponics system. It's a testament to human ingenuity, to our ability to come up with creative solutions to complex problems. If one inventor can design a system this efficient, this resilient, this productive, imagine what we can achieve as a community, as a society. Especially when we start combining ideas from different fields like renewable energy, vertical farming, water purification.
It's about taking those innovations and seeing how they can work together, how they can build on each other to create a more sustainable future.
Exactly. This patent, it's not just about off-grid living. It's about creating a future where fresh, local food is accessible to everyone, regardless of where they live, what resources they have access to. And that's a future I think we can all get behind.
Absolutely. This deep dive started with a simple vision, a plate of fresh food, and it's led us to a vision of a brighter, more sustainable future. It just goes to show that even the most complex challenges, they often have surprisingly elegant solutions. We just have to be bold enough to imagine them and determined enough to build them.